Alright, right now we are talking about power and radical functions, and I want to make sure you guys understand what I'm asking you to do as far as asking you to find the domain, the range, the intercepts, in behavior and stuff like that. So right now I'm going to turn my graphing calculator on. Alright, so we're going to put R in second plus, just clear everything out. Let's go ahead and put our equation. Now this right here says negative, it says negative 1/2. So what I'm going to do is I'm going to type in a negative 1/2. I'm going to open up a parenthesis so I can get this fifth root. So hit the math button and go down to number 5. I'm going to type in the number 5 here. So the fifth root of, I believe it's 6x minus a 12. Okay. I'm going to turn my grid lines on. So second zoom. Turn the old grid lines on. Okay. And I'm going to hit zoom number 4. Take a look at this graph. Okay. So let's think about where this graph is heading over here. Well, over here the graph, the x's are going definitely to negative infinity, and over here these x values are going to positive infinity. But where is the graph eventually going? Is this going up or is this going down? So check your table. Okay, let's check our table. Let's check our table right now and let's look at our y values. As the x's are decreasing, look what's happening to the y values. They're not staying constant. The y values are indeed going up. They're increasing. Okay. And as the x values are increasing, look what happens to the y values. All the y values are continuing to do what? All the y values over here are continuing to decrease as x gets bigger and bigger and bigger. Okay. So right now what we're going to do is we're going to graph a few points here. Let's just start at 0. Alright, we can do 2, 0, and 0 is close to a 1. Alright, and at 6, looks like it's pretty close to a negative 1. So right now, let's go ahead and graph this to the best of our ability. Alright, so it definitely crosses right here at 2, 0. Gets right about here. It looks like this line goes really close to that 1. It crosses over and down through. Alright, so this is the fifth root of this. It gets pretty close to that. Now our domain is all real numbers. So I'm going to say the set of all x values such, well, you know what, that x is an element of the real number system. But instead of using set builder notation, let's go ahead and use interval notation. It's a lot easier. Our domain goes from negative infinity all the way to positive infinity. Okay. Now the range is also negative infinity to positive infinity. Alright, so the range up here, the range is going to positive infinity, but here it's going towards negative infinity. But the range includes all those numbers from negative infinity to positive infinity. Now the intercepts. We have two intercepts. We have an x-intercept, and that's pretty easy to see. The x-intercept is right there at 2, 0. We also have a y-intercept. Now where is the y-intercept located? It's located at 0, comma. Let's plug in a 0 right here. Plug in a 0. If I plug in a 0, then I'm left with a negative half times the fifth root of a negative 12. Okay? And what you end up getting, what's that approximately equal to? There's a decimal, and that decimal is 0.82. That's what the decimal is equal to. So if I wanted to give the approximate value, you could say it's equal to a 0.8. But technically it's 0, comma, negative a half times the 5th root of negative 12. That's the exact y-intercept. This is your x value, there's your y value. Now, let's look at the end behavior here. All right? What I'm going to do right here is I'm going to make what's called the left end behavior. I'm going to put left end. And then I'm going to do right end behavior. And I'm going to make a column. Separate these answers out for y'all. Okay? So the left end behavior. All right? So let's look over here. Where are the y values going over on the left side? The y values are going to positive infinity. Well, what's happening to these x values? These x values are going towards negative infinity. So you would say the limit of f of x is equal to positive infinity as x approaches negative infinity, which basically means that as the x values are decreasing, the y values are increasing. Now the right end behavior is what's happening over here on the right side. Where are the y values going on the right side? They're going towards negative infinity. So on the right end behavior, you'd say the limit of f of x is going towards, it's going to equal negative infinity. I realize it'll never reach negative infinity, but that's the limit of it. As x is approaching positive infinity. And that's the right end behavior. So when it's asking for the end behavior, it's asking for two behaviors. One on the left side, one on the right side. Now is this function continuous? Yes, it is continuous. There are no breaks in the graph. There are no asymptotes. There's no jump discontinuity or removable discontinuity. Okay. The cool thing is that's the 5th root. So you can pretty much put any odd index right here. You can plug in any number you want. Okay, so the continuity right here, you're just going to say yes. Now this function is definitely not increasing. All right, so there's no increasing happening. There's nothing happening, but it is decreasing. It's literally decreasing from the time you see it at negative infinity till the time it's going towards positive infinity. It's just decreasing at a very, 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 very slow rate. Okay, but it's decreasing the entire time from the left to the right. So that's what you're doing on these problems. You're looking for what's the domain, what's the range, where does it cross the x-axis and where does it cross the y-axis. Here's your left end and right end behavior. It's asking you if it's continuous or not continuous. This is yes. And whether the graph is increasing or decreasing. So that's what you're doing. Hope this was helpful. I know it's just one example, but hopefully one example is better than no examples. Have a good day.